this video, we are going to formalize some of the properties we've been talking about in chords. So the first property is talking about either in the same circle or in congruent circles, we have two minor arcs are congruent if and only if their corresponding chords are congruent. So we're talking about the arcs, so like this minor arc and this minor arc are congruent as long as this chord and this chord are congruent. All right, so let's do some examples. In our first example, it says AB is 110, so that means that this arc is 110 degrees. So they want us to find the measure of arc BC. Well, since these are both 9, then we know that BC will also be the same measure as AB. So the measure of BC is also 110 degrees, since these two were congruent. All right, now in the second part, it's like we are starting over, so make sure you realize that AB is no longer 110. They're saying that AC is now 150. So from A to C, it's 150 degrees, and now they want us to figure out what is AB. Now remember that AB is still going to be the same thing as BC, and we're starting over, so we can't assume that these are 110. So we're going to, let's just call these like X and X. They're both the same. And remember that the whole full circle is 360 degrees, so I'm going to have X plus 150 equals 360 degrees. So if I add those together, I'm going to subtract the 150, and that's going to give me 210 degrees. And then I need to divide that by 2 to get just one single X. So that's going to give me 105 degrees. So in this second example, AB is 105 degrees. Now over here in this example on the right, we are given two congruent circles. So what's important to note is that these circles, P and Q, are congruent, which just means that their radii are congruent. So you see those are congruent. And then they also say that FG and JK are congruent. So then they said, if we know that JK is 80 degrees, then FG also has to be 80 degrees. So that's just an example of showing it in two different circles. All right, next property. If we have a chord, it is a perpendicular bisector of another chord. So here's a chord. That's a perpendicular bisector of this chord. Okay, so you see how it's perpendicular and it bisects. So those two pieces are congruent. And they're saying that that first chord has to be a diameter, so it has to go through the center. All right, now in this one on the right, this property, it's saying that if we have a diameter and it's perpendicular, that it's going to bisect both the chord and the arc. So this arc and this arc will also be congruent. So let's use those in these examples. And number 3, CD, we have to find the measure of CD. So here's CD, that's an arc. And notice that we have a diameter going through the center and it's perpendicular. So according to this second property that we just talked about, this chord will be bisected and the arc will be bisected. Right, so that means that 9x is going to be equal to 80 minus x. So let's solve. I'm going to add the x to the other side, so I get 10x, and then divide by 10, and I get x equals 8. Now remember, they're not asking for x, they're asking for CD. So I have to go back over here and plug in x. So I'm getting CD equals 72 degrees. All right, now DE, the measure of DE, well, we just said that DE is going to be congruent to CD, so this will also be 72 degrees. And then CE, okay, if I go the arc from C all the way to E, that's both of those arcs added together. So I'm going to be doing 72 plus 72, which gives me a total of 144 degrees. Now our last chord property says that if we have, again, the same circle or two congruent circles, we know that the two chords are going to be the same length. They're going to be congruent if and only if they're the same distance from the center. So this, let me mark that a different way. I'm going to highlight instead. So those chords, the red lines would be congruent as long as the distance to the center. So those highlighted lines are the same distance. So let's do an example with that. In this first example here, I've got QR is congruent to ST, or QR is equal to ST. They're both 16 units long. So those green lines are the same distance. They want us to find CU. CU is the distance to the center. So because those green lines are congruent, these two blue lines will be congruent. So CU and CV will be congruent. So I'm going to set 2x equal to 5x minus 9. And then I'm going to subtract the 5x. So I get negative 3x equals negative 9. And then divide by the negative 3. So I'm going to get x equals 3. Now remember, it's asking me to find CU, so make sure to read your directions. And we're going to plug in 3 and for x here. So I'm going to get 2 times 3. That's what CU is going to be. So CU is 6 units long. And then over here, we are trying to find the value of x. So x is this distance here. All right, and they tell us that this diameter is perpendicular to this chord. So remember, that means from above, that means that this chord is bisected. So that means this side is also 5. So what we have here is, I'm going to draw this out bigger so we can see that. I have this side is the 3 that they have marked. The left side is the 5 that we just said was congruent to the other 5. And then this hypotenuse is the x that they want us to find. So if we know two sides of a right triangle, we're going to use Pythagorean theorem. Just make sure that your x goes in on the c squared side. So if I square 3 and 5, then add those together, I'm going to get 34 equals x squared. And then I'm going to square root both sides, and that's going to give me 5.83. Now here I can stop at x, that's what they wanted me to find. So that would just be answer choice E. So that's what we needed to formalize for properties of chords. Please go to my 10.4 video that talks about inscribed angles and polygons.